Let's look at constant of proportionality. So in the last video, we divided, right, to find what what all of the ratios equaled to see if they all equaled the same thing. So you didn't know it, but we were actually finding the constant of proportionality. That's all it means, is that value that all of the ratios are equal to, right? So let's take a look. The table shows the proportional relationship between the number of uniform shirts for a soccer team and the cost. Determine the constant of proportionality. Now something that we have to talk about is independent and dependent. I talked a little bit about it in the last video. So you always want to figure out which one is X and which one is Y. X is your input, Y is your output. X is your independent, Y is your dependent. So here in this example, the number of shirts and the cost, well, the amount of money that I have to pay is going to depend on how many shirts I buy, right? So Y is dependent on X. Now, this example, usually when you have a money example where items cost money, the number of items will be your input and the cost will be your output, right? Because how much you spend depends on how much you buy. So let's determine the constant of proportionality. So just like we saw before, we're going to divide, right? We're going to see, it says it's a proportional relationship. So that means that when we divide 75, let's see, let me write it over here, 75 by 6, we should get the same thing as when we divide 137.50 by 11 and 200 by 16. So let's see what they equal. They should all equal the same thing. Actually, I'm just going to write them all together because we're told that it's proportional. So we know that these ratios all equal each other. And now let's see what that actually equals. So I'll do the 75 divided by 6. 75 divided by 6 equals 12.5. Now think about what that means, right? I could write this as 12.5 over 1, right? That means the same thing. And if you look at what I've got on top of my fraction and what's on the bottom, the top of my fraction is the cost, and the bottom of my fraction is the number of shirts. Right? So that means over here at the end, when I found my constant of proportionality, this is the cost for one shirt. Okay, so the constant of proportionality is 12.5. Now this time, as opposed to the last video, this time it does matter which order I do the division. If I had done the number of shirts divided by the cost, that would not be the constant of proportionality. It would give me a decimal, and they would all be the same decimal. They would all be equal to each other, so I could show proportionality. But the constant of proportionality is Y divided by X every time. And we have a variable that we use to represent the constant of proportionality, and that variable is K. All right, so if it says to find K, that's the constant of proportionality. All right, let's try another one. A recipe book shows measurement conversions for cups to tablespoons. Shows that a quarter cup equals 4 tablespoons and 3/4 of a cup equals 12 tablespoons. Write an equation that shows the proportional relationship between cups and tablespoons, where C is cups and N is tablespoons. Okay, so let's find the relationship here, right? Let's find the constant of proportionality. Now, for this one, it is converting cups to tablespoons. So I'm going to take cups as my input and then tablespoons as my output, right? We're converting from cups. We're starting with cups to tablespoons, right? So we're inputting the number of cups. We're getting out the number of tablespoons. Cups is X, tablespoons is Y. All right, So that means to find my constant of proportionality, remember, I'm going to do y divided by x every time. So for the first relationship, I'm going to do the tablespoons divided by cups. So that's going to be 4 over 0.25. Now I could just use that one. I could also use 12 divided by 0.75. They both equal the same thing, right? So when I do that, let me do 4 divided by 0.25. I get 16. Now, I'm going to write that as a ratio. I'm going to write 16 over 1 because remember what I'm measuring on the top and the bottom. The top of my fraction is tablespoons. So I'm going to write that with a capital T, right? This is tablespoons. The bottom of my fraction is cups. So this tells me that 16 tablespoons equals 1 cup. Okay, so now how do I get this equation that they're talking about, right? So my value of k, I want everyone to look at this equation here and think about when we did solving equations in the last module, right? If I put this, I know that this is k, right? This is my constant of proportionality because I did the y divided by the x. I got 16. So I'm going to put 16 in for k. So I know that 16 is equal to y over x. Now that is an equation. But usually when we see these equations that relate one quantity to another, it's going to be y equals. Almost every time it's going to be y equals. So I need to get this equation to just be y equals. So just like we did with solving equations, when we see that the variable is being divided by x, the way to undo that is to multiply by x. So I'm going to multiply by x on both sides, and I'm going to get y equals 16x. Now that brings me to a second equation that you can use when you're writing equations for a constant of proportionality, and that is that y equals kx. All right, these two equations that I just circled up here, k equals y divided by x and y equals k times x, are equivalent, right? They mean the same thing. They're just written a slightly different way. So that means that as soon as I figure out k, like right here, I knew that k was 16, I can just substitute that value of k right in there and I have my equation. Okay, but I didn't just want to say, here's the equation, plug it in there. I wanted to show you why that equation is the same. And it's because we took this first equation and multiplied on both sides by x. Okay, so that makes it an equivalent equation. All right, so this would be our equation. Oh, wait, it says C and N, right? So this should be C, right? Because x is cups, and this should be N. I have to follow those instructions. So N equals 16C. Okay, let's try one more. The graph shows the proportional relationship between time in minutes spent skateboarding and the number of calories burned. Determine the constant of proportionality, then write an equation, right? So we have our two equations. I'm going to write them up here at the top. We know that k is going to be found by doing y divided by x. And once we have k, we know that we can just put it right into this equation, right? We just put the number right there. Okay, so we need a y and an x. Now, thankfully, we have a graph. I say thankfully, right? Thankfully, we have a graph. And on this graph, we are able to see points, right? So let me write some points here. Let me get a darker color so we can see. So I could take any of these points because I can clearly see what they equal, right? And what I mean by that is, let's say I take this point right here. I can trace this point down and see that the x value is 40. So it's 40. And then I can trace it this way and I can see that the y value is 400, right? And I can do that with any of the other points that I marked too, right? So I can see that this one is 150 and this one is 15, right? 15 and 150. Here's the good news. When you're determining your constant of proportionality, you can use any point you want. So I'll use the 400 divided by 40 point, right? So I'm going to do, to find k, I'm going to do y, my dependent, divided by x, my independent, and I get 10. So now that I know that k is 10, I can just put it right in here. Oh, sorry about that, you guys. I can put it right in here, right? So I just have y equals kx, and instead of the k, I'm going to replace it with 10. That's my equation. All right, as always, let me know if you have questions.